Good evening, sir.
So, the Department of CSC, Sri Vishnu Engineering College for Bhimavaram, we welcome you to this faculty development program, madam. So, despite of your busy schedule and this odd time, you joined with us to share your valuable insights, madam. Before entering into the session, let me take to introduce you, ma'am. It is my great honor to introduce Dr. P. Deepalakshmi. Dr. B. Deepalakshmi, working as a professor and head of the Department of Computer Science and Engineering, Dean, School of Computing, Kalasalingam Academy of Research and Education, Tamil Nadu. She received her PhD in Computer Science and Engineering from Kalasalingam University on 2013. She did her ME in Computer Science and Engineering, Arulmegu Kalasalingam College of Engineering under Anna University on May 2005, got first class with distinction. She had industry experience in Patni Computer Systems, Mumbai, as roles of software engineer and project assistant. She has current membership in professional organizations like ACM, ISTE, CSI. She has funded projects worth of 84 lakhs and a consultancy projects of 1,30,000. She had 7 patents filed of national and international. She published 2 books and several book chapters. She backed several journals with the Psi Impact Factor and Scopus Indexed. She published many conference publications with Scopus Indexed. Under her supervision, 7 scholars completed PhD, 1 thesis submitted, and 9 are in progress. She delivered several lectures and successfully done many professional development activities. Really, we are very glad to have such an eminent personality as a resource person to this faculty development program, madam. Now, I hand over you the session to enlighten us with your valuable insights.
Thank you, sir. Thank you for the nice introduction. Hope I'm audible to everyone. Before I start my presentation, I would like to thank Professor Kiran sir, who has invited me to give a talk as part of this FDP on societal applications of machine learning, which is in fact a topic very much needed for the time. We know how machine learning is influencing both the industry as well as the academic research. So a very nice title. Hope in the last 5 days, the participants would have gained a lot of knowledge and how the machine learning techniques have been used in a variety of applications. I would like to thank the college, the management, the department, HOD, and the faculty who have given this opportunity to me. So with the permission of the chair, organizer, and all of the participants, let me share my presentation. Sir, is it enabled, presentation sharing?
Yes, madam, yes.
Like, can you guide me like how to do it?
You have a share button, madam, just adjoining to this camera. You have a share button like.
No, I don't have. I don't have. I have this camera button and then audio button only.
After that, you need to.
Yes. 1 minute, sir. Please confirm whether you are able to see my screen.
Yes, madam. Your screen is visible, please.
Yeah. So as introduced by the faculties and Kiran sir, myself Dr. Deepalakshmi, working as the Professor and Dean School of Computing since the year 2004 in Kalasalingam Academy of Research and Education. So the topic I have taken today is detection of DDoS attacks using machine learning techniques in software-defined networks. So many of you might have listened to the application of ML techniques in the healthcare sector, mainly related to the data analytics, maybe image analytics or audio video analytics or text data analytics. I don't know, I mean, anyone has handled a topic related to this networks. So I thought like based on the exposure I have in the networks, I can take the topic how we can detect the DDoS attacks in software defined networks. So let me just introduce about software defined networks to all of you. We know about the traditional networking architecture where we will be having a lot of computers connected by the intermediate devices. The intermediate devices will be doing the job of both control function as well as forwarding function. Whereas in software defined networking, this is in fact decoupled. That is, the control function is decoupled from the forwarding function. So here you can see in a software defined networking, you are having three layers, three planes: application plane, control plane, and then data plane. So here data plane takes the responsibility of forwarding duty, means that you will have a table, and then whenever packet comes in, the destination address will be looked into the table. Based upon the guidance given there, the packet will be forwarded through the concerned outgoing path. All of us know this. So this function is restricted to the data plane. So you can see here the presence of the physical switches, virtual switches, as well as the hosts. Above this, you are having a control plane. So this plane is actually separated from the forwarding functionality. This is mainly kept to control the network. So the network management, in fact, happens in this layer only, that is control plane layer, where you will be having the SDN controllers. Initially, they have started with a single controller, okay, because they wanted to give the control to a central authority. So they had only one controller. But now we have SDNs with multiple controller architecture also to avoid the single point of failure, in fact. On top of this, we have the application layer. So you can see we have network virtualization, security, memory management. So all these are part of the application planes, in fact. So here the network management, instead of doing it manually, means you have a dedicated administrator, he set the policies, he execute the policies, he troubleshoot wherever the problem comes. Instead of doing like that, this has become entirely programmable. That's why it's called as, in fact, software defined network. So the network management is automated over here, and it is in fact programmable here. So what are all the security issues we have? Before that, let me tell about the southbound API and the northbound API. The communication between the control plane and the data plane, it takes with the help of the southbound API, whereas between the control plane and the application plane, we have the northbound API. We in fact have the attack in both the southbound as well as in the northbound. That is in the data plane as well as in the application plane. So if you take southbound, what are all the vulnerabilities we have? So the data plane nodes can be compromised. Means what are all the devices you have in the data plane? The computers, the host, the virtual switches, as well as the physical switches, these can be compromised. So once your device in the network is compromised, you know what are all the jobs an intruder can do in the network. So mainly DOS, that is denial of service, distributed denial of service, data modification, and repudiation. All these attacks can happen if the data plane nodes are actually compromised. So based on our basic security knowledge, we know what is meant by data modification, we know what is meant by repudiation, and all these things. So denial of service is actually a special kind of attack where the service is refused to the legitimate user. I cannot use the term refused. Instead, the service becomes non-available to the legitimate users. That is in fact the correct term. This is done by the attacker, in fact. So now, if you see the northbound interface, that is the communication between the control plane and the application plane, you have variety of attacks here. Here also, this is the place where the major attack is happening, because this is the place where you have the responsibility for network management. So if you attack here, entire network will become collapsed. So this is in fact the place of aim for the attackers. So here also you have DOS attack, DDoS attack, black hole attack, fake flow rules, in fact. Okay, so when you normally send packets to your destination, when it comes to the switch, it will look into the table, either the forwarding table or the routing table. So if an entry is found for the destination, immediately the data will be forwarded in the concerned outgoing path mentioned in the forwarding table. Otherwise, the switch will determine a new path searching for the destination. That is the job of the routing protocol and routing algorithm. By sending hello packets, so many protocols already we have learned, link state protocol, OSPF we have. For regular networks, for wireless networks, we have different protocols. So using these protocols, the switch will come to know the path to the destination. So it will create an entry in the flow table or otherwise a forwarding table. Then the first packet will be forwarded there, and all the subsequent packet to the concerned destination also will be forwarded there. So this is the regular flow. So here also we may have an attacker. We may have fake flows. Okay, so the fake flow only are going to disturb the network, in fact. So if the controller is compromised, there can be wrong paths. Okay, and a lot of packets may come, so that the network will be overflowing, the bandwidth will be affected, there won't be enough bandwidth to receive the data from the actual legitimate users. So all these issues will happen, in fact. So if we see the other security issues, I mean, as I said, when we had the single controller setup, it is the in charge, I mean, main in charge or major or one and only in charge for the network management. If that controller is compromised, that point becomes as the security threat, in fact, for the entire SDN. And if the controller gets compromised, what the attacker can do, whatever rules, policies are defined by the controller, he can rewrite based on his intention, so that the legitimate users will not get the resources. Okay, early detection of these kind of attacks have been focused only by few researchers, because SDN is programmable. Generally understanding the networking architecture, the principles, and then the management, it's tough. And again, to overcome an attack, that's in fact a more challenging one. Okay, and separate solutions are provided to the data plane threads and then control plane threads, whereas providing a common security mechanism to both the planes, okay, it's still, I mean, a challenging one. And some of the researchers have tried in a different way to detect different attacks. In that, we have a low rate attack as well as a TCP flood attack. The detection mechanism for these attacks is still, I mean, in the infant stage. And when they analyze the packet data also, random features are selected to train the machine learning methods, rather than detecting which features are more influential in detecting the DDoS attacks. So the attacks which have low false alarm rate, early detection of these kind of attacks, that is also still to happen. So all these, I mean, are the possible security issues we have in SDN, where the researchers, in fact, can focus. So to talk more about the distributed denial of service attack, you can see the users, they are all legitimate users. The red colored faces, they are actually the attackers. So as part of the regular users, these people are also flowing the packets towards the target server. So instead of getting, say, for example, 10 packets or 20 packets, the server now will be getting thousands of packets, because continuously the flow will be generated by the attackers. So the target is almost surrounded by the lot of traffic, in fact. The attack can be from single attacker also, or maybe from multiple attackers also. The attacker can directly send a packet to the server, or otherwise the attacker can compromise some of the users here, and then he can turn the regular users also as the attackers. So in this case, a bot is actually created. So the attack will happen from multiple sources now. That case only is called as the distributed denial of service. So if only one attacker is there, it is normal DOS. If there are multiple attackers with the compromised nodes targeting the server, it is called as distributed denial of service attack, in fact. So there are three types of DDoS attack. protocol attacks, volume-based attack, protocol attack, and then application attack. So if you take a volume-based attack, the name itself says you just flood a lot of traffic to the network. This is called as the volume-based attack. Mainly this you are doing to occupy the bandwidth, to occupy the network equipments. DNS server request, it is in fact an example for this volume-based attack. Next, you are having the protocol attack. So there are different type of protocols serving different jobs. For example, you may have firewalls. You may have firewalls to protect some of the websites also, and there can be the load balancers also. So attacking these things with the help of the protocols, that is actually called as the protocol attack. The last one is the application attack. So normally here the attackers will be using the zombie networks so that the web page, for example, you are accessing the web page www.123.com/learning. Okay, so this page we want to access, but continuous request is made to this page so that this page will not be available for any more user. This kind of attack is called as the application attack. So if a web page is actually not available, then we can say that it is an attack happening at the application level. So DDoS attack can fall into any one of these three types. Yeah. So what are the symptoms and what are the different protection tips we have? So slow access to files. Access obviously becomes slower, and then we are not able to access a particular website or a particular web page. The internet gets disconnected, and we have problem in accessing all kind of websites, and there is an huge amount of spam emails found in our inbox. That is also in fact the reason for the symptoms of the DDoS attack. So how we can protect them? We always need to protect our IP addresses. That is the first job. Otherwise, spoofing will happen. Then you can use a virtual private network also. Instead of using the common, a network structure, form a virtual private network. Okay, then go for the communication. Then phishing attacks, you all might be knowing. Okay, so we need to be aware of this also regularly. And whatever is the application and softwares we are using, we need to update them continuously. You also might have seen when you use either your laptop or your mobile phone, many a times update comes, we feel it as a disturbance, but it is not actually like that. Every day lots of attacks are happening, and every day the solution providers, they improve the security also. That is why updates are actually happening. Basic function wise, we may not have an update majorly, but security wise, definitely we will be having the update. And then always have antivirus software in your system. That is another thing. So these are some of the noteworthy DDoS attacks that happened in the history of computing. The first attack is created in the year 2000. The first DDoS attack, it is created in the year 2000. A mafia boy. He is actually a 15-year-old boy who was, able to affect the CNN site, Amazon site, Yahoo site, and then eBay site. This is the first DDoS attack happened. Then Proton Mail in 2015. This is another one happened to Bitcoin. And then Dyn in 2016. Many of the tiny devices we have in the IoT architecture, he could compromise those devices and created this DDoS attack, and it affected the functionality of Twitter, The Guardian, Netflix, Reddit, and then CNN. Then recently in 2020 also, Amazon has faced this attack. Can you imagine the impact of the impact? Suppose Amazon server is not available for 2 days or 3 days. We know every minute Amazon does business for crores and crores of rupees. So if Amazon is not available for 1 day, how much will be the business loss? Can you imagine? Same thing to the other websites also, in fact. Then similarly in Ukraine also in 2022, recently war is happening. The Russian hackers actually have done DDoS attack. Why I have displayed this slide is the importance of DDoS. When a service is actually denied, it is definitely a loss to the business, whatever is the kind of the business. Even you take a mail server, you don't get a particular mail, continuously means obviously you will be moving from one mail service to another mail service. So everything it actually happens like this. So the protection from these DDoS has become the need for the day. In fact, in 2021 itself, around 20 million DDoS attacks has happened. Again, in 2021, we all know that Microsoft has this Azure server. Okay, they have generated, the attackers have generated 365 million of packets per second to the Microsoft Azure server. How the server, even though it is a supercomputing server, 365 millions of packets per second, unimaginable. So these were the, attacks that happened in the industry. That's why I conveyed this. So what about the DDoS attack role in the SDN? So here also the controllers can be compromised. The switches also can be compromised. If the controller is compromised, entire network is actually, disturbed. Whereas if the switch is, disturbed means the forwarding job cannot in fact happen. That is the problem we have in the, SDN. So, DDoS attack in SDN can affect both the server, means controller, as well as the switches. That is data plane as well as the control plane. Okay. So challenges in detecting the DDoS attack in case of SDN. Okay, so we have the packet header field. This gets modified, and the packet looks like they are coming from the legitimate users. So this, this creates the difficulty of detecting the actual, source from where the attack is coming. So to know that the attack has happened, we needed to verify a large number of packets. And sometimes the source doesn't know that it is compromised by the attacker. Being a legitimate user, I may not be aware that I am compromised by the attacker, and in my name the packets are sent by the attacker. I may not be aware of these things. And generally, if there is a flow already registered in the forwarding table, the switches will not check anything about the packet. Whenever a new flow comes only, all these application, the rules, policies are applicable. So that time only it will check whether the flow is actually legitimate or not. And periodically only now the security checking is happening, and it is not there as a regular practice. So these are all the challenges that we have. So we have, both high rate as well as low rate DDoS. You can understand the meaning. High rate means it will occur in a burst. Means suddenly a lot of traffic will be coming. This at least we can sense. Whereas low rate DDoS attack, it is very difficult to detect because it will be like a normal flow, less packet size, very less low rate. Means what I can say, high rate and low rate. One high rate is actually, the poison, okay, which will give an immediate. The immediate death like that, whereas the low rate attacks, it can be a slow poison. You yourself won't know like you are consuming a poison, but at the end, after a certain amount of time, definitely it will have an impact on the health. Similarly here also, high rate you can detect, you can see the effect immediately, whereas low rate, it is also, very serious threat, but you may not be able to sense the impact immediately. So now let us see what are all the machine learning techniques already applied here. So I have a lot of literature. I'll just go through this. For example, SVM is applied, and then the entropy techniques are also applied. So here you can see a lot of the packet informations are checked. For example, source IP, source port, flow packet, flow byte, flow entries, and then pair flow, all these things. So here SVM algorithm, they detected, they used SVM to detect DDoS attack, but the accuracy is in fact relatively low here. Whereas in the second case, they used the entropy mechanism to detect the abnormal variations in fact. So here the false positive and negative rate is in fact very higher. Similarly, they have used, the best subset algorithm for the feature selection, and they came up with the misbehavior and attack detection module. These papers, of course, one need to refer completely again and again to understand how the algorithm is used in detecting the attacks, in fact. And in the fourth one, they have used the artificial neural network to detect the UDP attack, TCP attack, ICMP attack, protocol level DDoS attack. So this is able to detect both the known attacks as well as unknown attack. But for that internet control message protocol, it gave only low accuracy, in fact. The next one, so this is the summary, in fact. So here you can see SVM is used, K-means is used, K-media is used, KNN is used, neural network is used. Not only the machine learning algorithm, the deep learning algorithm also, CNN, LSTM, all these algorithms are used. Statistical techniques like Shannon, generalized, and information metrics, these techniques have also, were used by the researchers. So in SDN, they used both the PAX controller as well as NAX controller and open flow switches. The data set is available in the internet. Means, see, basically for these things, what is the data set? The log file. Okay, so when every packet is passed, we have the information about the packet. So there will be malicious packet as well as the regular packet. For example, you may have 1 lakh number of packets. In that, there may be a 10% malicious packet present here and there. So to these data, you need to apply your machine learning techniques, and then you need to develop the model. Once you develop a model, you can deploy in the real-time environment, and you can see what is the accuracy in fact. Okay, so what are all the issues identified based on these studies are obviously detection of the attacks in the early stage. That is very much required. Otherwise, network will be severely affected. Okay, and then we need to fix a threshold value which can lead to the false alarm rate. And random feature selection is no more useful. It can lead to only poor accuracy. So we need to be careful in the feature selection, in fact. The next one, we are having the low rate DDoS. And as I told you earlier, it can be a slow poison, but whether it is slow or fast, poison is a poison. Okay, so here also low rate DDoS attacks. This and all is given only very less attention by the researchers. Okay. So here also the support vector machine, it is tried multi-layer perceptron, it is tried random forest, random tree. See, these research and all happen very recently, only 2022 like that. Okay, so here the authors they suggested that multi-layer perceptron, it is able to give better accuracy compared to the other techniques. The data set they have taken here is the Canadian Institute of Cybersecurity DOS data set. Okay, and in the next paper, low rate DDoS attack detection using expectation of packet size. So here also they used the real-time data size with various tolerant factors. So here they claim that they are able to detect the DDoS attack. So here they propose to the packet size measurement technique. After analyzing the packet size, okay, that means if you have a continuous flow of least packet size, you can sense that it is a low rate attack detection. After all, machine learning is working for pattern detection. Okay, same thing is applicable here also. Similarly, the other techniques in the literature, we have a lot of techniques for this. Low rate DDoS technique. So this is a summary. We can see variety of machine learning techniques are applied. SVM, J48, MLP, REP3, random forest, KNN, and a neural network. Similarly, variety of statistical techniques are also applied. So here also PAX controller is used, open flow switches are used. These are all the data sets available. From MIT, we have a data set, in fact. So here also they conveyed like we need to detect it yearly, whether it is a low rate also, we need to detect it yearly, but it is very, very difficult to detect low rate DDoS attack because it sounds like a legitimate track. Statistical techniques may not be of much useful because they suffer from the high false alarm rate over here. And again, here also feature selection needs to be focused more, in fact. The next one is the TCP flood attack detection. We all know TCP handshake mechanism. For example, I am there as a client, you are there as a server. I want to establish a secure communication channel with the server to get the response from the server. So I will be sending a message. Okay, hello message or a synchronization message, SYN message. So the server actually will be sending the synchronization message along with the acknowledgement message. For that, the client again has to reply, okay, I accept, like that. Now, what will happen in this TCP flood attack is the client will be sending the synchronized message, that is hello message. Server will also respond with the synchronization plus acknowledgement message. For that, the client will not reply. Means first message is sent from client to server, second message is sent back from server to client, but third message will not be sent. We used to call this as handshake mechanism. Okay, but this handshake mechanism will not get complete if third message is not sent by the client to server. So what the intruder is doing, he opens lots and lots and lots of handshake signals like this, but he won't close it. So automatically what will happen? Automatically what will happen? The server will become overloaded. That is actually the issue over here. So here also many researchers in fact have proposed many algorithms. So to summarize, SVM, random forest, multi-layer perceptron. These were the major machine learning techniques applied by the researchers, and entropy-based as well as proxy-based techniques have been used under the statistical techniques category. So here also path controller, open flow switches were used. Many people have tried the CADA data set. Okay, so here we needed to address this synchronous flood attack also separately, acknowledgement flood attack also separately. Synchronization messages are in fact flooded by the client. That becomes the attack in fact. Okay. Here also, whenever you have a high traffic, statistical mechanisms may not work efficiently. So we obviously need to go for the machine learning mechanisms. Okay. And suppose if you have a fixed entropy values, it may affect the detection accuracy. So what is required? Continuous monitoring is required and continuous inspection is also required, but this may take more time to detect the attacks. So see, these are all the possible DDoS attacks one can concentrate on. For that only I'm conveying this information. And above all these things, okay, you have a multiple attacks. Why you need to develop a separate mechanism for detecting separate attacks? Why don't you go for an IDS? We all know IDS, intrusion detection system. So you can come up with an intrusion detection system also for a software defined networking. Many researchers have proposed different algorithms and detection mechanisms here also. So flow-based intrusion detection is there, flow-based anomaly intrusion detection is there. So I have given in the description the accuracy, what is lacking there, what is good over there. One can read the concerned paper also to get more idea into that in fact. So using fuzzy systems also, hybrid methods also can be used. So different data sets are used in fact by different researchers for proposing the ideas in the SDN in fact. So many algorithms are there. So to summarize this, I'm not having enough time to explain everything. This is a lot of literature. Many papers we have from China, in fact, SDN. Many papers we have, we can refer to know about the more and better security algorithms for SDN. So, to summarize, C4.5, naive-based, SVM, PZA, principal component analysis, GA, genetic algorithms are very much used. Okay, and the feature selection techniques, which I already told in the beginning, random features may not work well. See, if you take a packet header, there is many information present in the packet header. In fact, so you cannot, randomly select the features. You need to focus which features give better accuracy. So correlation-based techniques and then forward-backward feature ranking, information gain, cuttlefish algorithm. These are all some of the suggested algorithms by the researchers for the feature selections. So here you have many data set, KDD 99 data set, NSL KDD. This NSL KDD data set is also another famous one. And you can use different tools also for traffic generation. SCAPI is a traffic generator rule, in fact. Okay, so if you simply use a raw data set, it increases the complexity. And as I told, the random selection, it leads to poor accuracy, random selection of features. So single classifier may give you lower accuracy. So you may go for the multiple level classifier. Means you should start adopting the hybrid techniques. So deep inspection of the packet is required. Instead, looking at very, least amount of features from the packets. So intrusion detection, it is of two types. One is the signature-based IDS, and another one is anomaly-based IDS. Signature-based IDS is mainly helpful to detect the known attacks. But always we may not be able to predict that only known attacks will come. New attacks also we may get. So if you want to predict some unknown attacks, the anomaly-based IDS technique is in fact, it is better. So as I told already, in 2021 itself, 20 million DDoS attacks happened in the network in the entire world. So every second we are getting new kind of DDoS attack. In that case, signature-based IDS is not sufficient. We need to go for the anomaly-based IDS. So if anyone wants to prefer an IDS, developing IDS for SDN, they can plan for anomaly-based IDS. Expect the unexpected. That is what is the motto behind this anomaly detection. So flow-based IDS also. Per flow also we may have issue. It's not like that once the flow is started, it will go perfect. We may have issues in the flow also. So flow-based IDS also one can actually design. This is followed in traditional network. It is applicable to the SDN also. Flow-based IDS can be designed using either the statistical technique. Statistical technique is much useful when you have a high false alarm rate. You can design algorithm using machine learning techniques also. This usually detect the attack with better accuracy. You can go for either single machine learning model or you can go for the hybrid machine learning model also. So single machine learning model, it takes long time to pre-process, means it takes time to develop the model, detect and classify the attack whenever you go for the large data sets. At the same time, when you go for hybrid multi-learning model, accuracy is improved. Okay? And so why hybrid machine learning algorithm? Recent research, if you take, most of them have clubbed more than one machine learning model for detecting the attacks. Okay, so this integrates several machine learning attacks. This helps to achieve better accuracy and low false alarm rate. Normally, two algorithms you may use. First algorithm output will be used as the input for the second algorithm. So in case of this DDoS attack detection, clustering techniques, they are mainly applied to the raw data. So that you can do the pre-processing, you can omit the irregular data from every category. Then this processed data can be fed into the other machine learning algorithm so that you will be using, you will be getting the better accuracy. So generally, researchers now come up with the hybrid machine learning techniques for the detection of the DDoS attack in SDN. So feature selection techniques, flow-based techniques, signature-based techniques, all have become the need for the day in case of the SDN. So every technique, helps for different purposes. Accuracy is improved. Relevant features are considered. Computation cost can be reduced, and the overhead in the SDN controllers can be reduced. These are all some of the uses we get from these kind of techniques, in fact. So what are all the new research directions we have when we consider about the DDoS attack in SDN? So we need to detect both high rate as well as low rate DDoS attacks by analyzing the packet counts and the IP addresses. Packet count play a significant role because a single source, single destination. A single source, multiple destination. Multiple sources, single destination. All these are the combination for the DDoS attack. focusing on a single target or multiple target, focus from a single attacker or from multiple attackers. All are actually possible. So early detection of these attacks before they reach the server. That is good for the network, because server is compromised means network will become to a halt. Either server performance will be degraded, server will become halt, or server may get turned off also. All these things are possible to happen. Ensemble based feature selection may lead to a better classification. Okay, so generally for SDN attacks, ensemble based feature selection is suggested. So you can come up with a security mechanism so that between the controllers and the devices in the data plane using the machine learning models. Also, you can propose a host-based intrusion detection system. Instead of the controller-based detection system, you can have a host-based intrusion detection system also to protect from the insider attack. Sometimes legitimate users, they themselves can play. We know, like some of the employee can be a big threat to the organization. That is what is the insider attacker. We can also design a defending mechanism against the third-party applications so that we can provide a secured internet web application and services. So the software defined networking mainly is there when we use the internet only. So to get the security, while we accessing the web applications mainly, the defending mechanisms can be proposed against the third-party applications. So these are all the possible research directions we have in the DDoS attack detection in case of SDN. So this much information only I could provide in the time restriction given to me. In fact, this is a research which we did for years and years. More than 5 years. And even one of my scholars, she also is doing DDoS attack detection using machine learning algorithm. She just had her comprehensive whiteboard today morning. So we will be taking this research for another 3 to 4 years also, because every day DDoS attacks are coming, which we need to, protect the network. And then the better solution is not only detection, the better solution is always prevention. Prevention is possible only if you know the pattern. To identify the pattern, we need the machine learning techniques. That serves the purpose of this topic. Thank you, and I'm open to the queries now.
The participants, if you wish to interact with Madam, you can unmute yourself and you can have your queries addressed, please. The participants.
Good evening, ma'am.
Please.
Good evening, sir.
Your presentation is very nice, ma'am. Thank you.
Thank you. Thank you.
I want the detail about you are telling that some of the tools. So Bonify and Escape. What is meaning that, ma'am? How can use the tools in Python?
Actually, here either you can use the data set which is directly available, and you can implement your algorithm in Python itself to pre-process the data as well as to detect the attack using any of the machine learning model. Hope you know to implement the machine learning models in Python. That is one thing. Okay. Another thing, you can generate the traffic also on your own. You can generate your own packets. In that, both regular packet also will be there, attack packet also will be there. Then you can use it, to train your model also. So these are, whenever I say controller, whenever I say a traffic generator module, these are all the things which are available, almost open source only, readily available in the internet. You can download these things. You can learn very easily with the help of the help files available in the net itself. And when you read the papers itself, automatically you will come to know which tool is used for which purpose. From that, you can gain the experience and you can do on your own.
Okay, ma'am. Thank you. Then you give the detail about what is a hybrid ML model, ma'am. What is meaning that?
Hybrid ML model means, for example, you know about ML models. For example, I say SVM. Okay, so SVM model is a single machine learning model. For every purpose, I mean, for the problem statement given to you, if you use only the SVM model and if you give the output, that is single machine learning model. For example, I take a data set, I give the data set to the SVM. SVM automatically does the classification, means whether it is a regular packet or an anomaly packet. Done, the job is done. Whether accuracy is low or high, you don't mind. I want to use only single machine learning model. That is single machine learning model. What is hybrid machine learning model? Okay, see, there is a data set as I told. One machine learning algorithm may not be able to give a better accuracy. One machine learning algorithm may perform well when the false alarm is actually high. Okay, when true positive is high, when true negative is high, all these kind of information you should know about every machine learning algorithm. And feature selection, you may use a different algorithm. Classification, you may go for different algorithm. Sometimes classification also, you may have two algorithms, top layer one algorithm, bottom layer one algorithm. More than one machine learning algorithm you are using for the same problem. Okay, to get the output. Input is one, output is one. In the intermediate, you are using more than one machine learning algorithm. It can be sequential, like first algorithm output is second algorithm input, or it can be parallel also. Both the algorithm function parallelly. Finally, you may produce the result. Like this, if multiple machine learning algorithms work together and give the output, that is called as hybrid machine learning algorithm. Hybrid, we know normal meaning, no. I mean, for example, dog variety itself is an example. Same thing here also.
Yes, ma'am. Yes, ma'am. I think so. What I understood, layer-based some algorithm you can assign and use. So that is expectation I asked.
Correct. That's what the sequential algorithms. Yes.
Okay, ma'am. Thank you, ma'am. Thank you.
Thank you. Thank you.
Ma'am, good evening, ma'am.
Very good evening, ma'am.
Ma'am, is it possible to apply a real-time data set for any other method, ma'am?
It is possible, madam, but you need to get it from the SDN setup. We don't have a software-defined network setup here. We need to depend upon some of the universities in the abroad to get. For example, I told MIT is having a real-time data set. Normally this data set is not taken day to day. About the research, the real computer science research flavor is happening in the industries. I told you, like a lot of the attacks are happening every day, in fact. So these companies, they hesitate to provide the data set to the researchers. That is the reason why we get a 15 years old data set, 10 years old data set like that. We won't get a recent data set instantly from the companies. If you want to get a real-time data set, we need to create our own SDN and we need to get it. That's the issue with the real-time data set always.
Okay, ma'am. Can you say what is the maximum level of accuracy so far we have been rectified the corresponding problem, ma'am? Maximum accuracy.
Researchers report 99% accuracy. Researchers report, in all the research papers, whatever we take, we see 99%. The single machine learning model, obviously.
Hello?
Madam, you are muted. Dr. Deepalakshmi, madam, please unmute yourself, please.
Yeah. Am I audible, sir, now?
Yes, yes.
Yes, sir. Yes.
Yeah. So, you were asking about accuracy, right? Yeah, the accuracy actually, it depends. Earlier machine learning models, they have even reported 40% accuracy also in the beginning. Then they came to 70% accuracy. Now all of them are reporting good accuracy only. Thing is, when you have a known attack, always accuracy level is more. When you have an unknown attack, till you train the model, accuracy will be less only. After that, obviously, once you detect the pattern, accuracy will be improved. But since every day we get new DDoS attack, for every new attack, accuracy will be initially lower.
Do you think that is it possible to fulfill apart from that 90% accuracy? Is it possible?
99% accuracy itself, I will say it is a very big one when you go for a real-time environment, because this is not what to say, the network which we have in colleges like us. It is high-speed network in the backbone where millions of packets are handled per second. Okay, in a second the attack will happen. Where to get that accuracy? In future, of course, we may detect it actually, but 100% accuracy, no, not possible.
Okay, thank you, ma'am. Thank you for your answer.
Madam, can you hear me?
Of
Yes,
course,
yes,
madam.
please proceed.
Yeah, my question to you is that these whenever we are only getting the 40% accuracy, but we are for unknown attacking.
Yes, madam.
But whenever we are purchasing so much, these softwares are so much expensive. So how can we tackle? We are losing our data at that time. How we have to tackle this type of attacks, sir, ma'am?
Madam, handling, I mean, this answer is, general only, I can say. In fact, handling the data for the first time itself, attack for the first time itself, it is a tough job only. All of us are aware about Amazon Web Service. We know AWS, right? People who worked in AWS only will come to know about the high security level of AWS. Just like that, we cannot do anything in AWS. So you think about Amazon itself is hacked for, not hacked, the service is denied for 3 days. Amazon website was not available for 2 to 3 days in 2020. Okay, so if that is the case, that 3 days, it is in fact, whatever IDS they had in AWS, it is 0% effective. So they took then many days to detect the attack and prevent the attack. So when an attack comes initially, if the trained model is able to detect, it is in fact well and good. But if the trained model, because of the algorithms we have adopted, feature selection techniques we have adopted, if it is not able to detect the attack for some, generally, one more information, DDoS attacks maximum of the time, it goes for 24 hours. That one day is enough for them to disrupt the service. Their mainly aim is making the service to be non-available. So in 24 hours maximum, the attack automatically will go off. So from the data set collected in that 24 hours, they need to produce a solution so that in future similar attack comes, it can be detected. Okay, so when you have a detection mechanism, it can go like this only. The attacking pattern, if it is detection, if it is predicted effectively, we can go for the prediction. Meanwhile, the data loss we may not be able to stop. Loss will be there definitely. We as the normal users may not be able to use it. See, we just know WhatsApp is not available for 7 hours. Twitter is not available for 6 hours. Like this information only we are spreading everywhere. We never realize that what is the thing behind this non-availability. Maximum of the time, it is this DDoS attacker. That time,
Thank you,
obviously, WhatsApp is stopped for 1 or 2 hours.
Thank you very much.
Thank you, madam.
Thank you.
Sunil sir.
Yeah, thank you so much, ma'am. So I
Thank
hope
you, sir.
all our participants, even this hard time, they are very much interested with your presentation, ma'am. Really, thank you so much for really enlightening our participants.
Thank you, sir.
Thank you so much.
Thanks for the opportunity given, and thank you all the participants. Thanks to Kiran sir also. I should really appreciate your job, sir. 24/7, you are working with AI techniques and then ML techniques. Hope you yourself have predicted the pattern of working. So you are very much successful in organizing and participating in such events also as the resource person. A lot of appreciations to you and sincere thanks also. Thank you.
Thank you, madam. Thank you very much and have a nice day, madam.
Thank you. Good night to all.
Thank you.